Here. Thanks for the organizers for inviting me. I appreciate it. My name is Ylan Segal. I'm from San Diego, formerly from Mexico City. I've been writing Ruby since 2009 and mostly Java before that. So in this talk, I'm going to try to go over a few examples of how I use my Unix environment to accomplish day-to-day programming tasks. I'll talk a little bit about how Unix processes work and how they get put together in the operating system, but it won't be comprehensive because I have 35 minutes. So my goal is to really whet your appetite and show you what kind of things are possible and hopefully help you be more efficient on your day-to-day programming tasks. A little background, there's some wars on the internet about what Unix is in uppercase and lowercase. Usually uppercase is when they write it in uppercase, it means it's the original OS developed in the 70s at Bell Labs, later AT&T. And then Unix lowercase, sometimes called asterisk, nix, or other monikers, is something that implements POSIX standards and basically quacks like Unix. The POSIX standards are a set of IEEE standards that stand for Portable Operating System Interface, which define the APIs that all Unixes comply with, and they were developed originally in the 80s. So BSD, which is what powers this Mac, is fully compliant. Linux is mostly compliant. Windows is not compliant. However, there's some hope. There's Cygwin, which makes gives you like a shell in Windows that makes it significantly compliant. And for the purpose of what I'm showing here, Cygwin should work just fine if you have a Windows machine. So the Unix philosophy. There's a lot of stuff that gets attached to the Unix philosophy. Usually stuff gets called like use small sharp tools. Sometimes people express it as do one thing and do it well. And one of the things I like the most about those kinds of restriction is that expect the output of one program to be the input of another program. And it's another program that you don't know about now. So that talks about how you want to format your outputs. So really the Unix philosophy is like a set of cultural norms and a philosophical approach to developing small but capable software. So it emphasizes building simple, clear, modular, and extensible code that can be easily maintained by the people that wrote it because they're small things, but also they can be composed and reused by other developers or the same developers for greater effects. So it's funny, I just got a sticker that says monolith, but the Unix philosophy favors composability as opposed to monolithic design. So how do we interact with Unix? The basic way we do is through bash, and the way you interact with most Unix environments is through a shell. Bash is a shell that you will find on any Unix system that you log on to. It's obviously available on your Mac, on Linux. Cygwin gives you bash. And it's not only a shell, it's also a programming environment. But it's very, very universal. It's very powerful. If you're programming in it, it's quirky, but to say the least. But it works. Again, on Windows, you can use Cygwin or use a virtual machine, which now with VirtualBox, that kind of thing, you can download a Ubuntu image and get it up and running relatively fast. So the first of the examples I'm going to show today is about tailing the log. So my first command that I want to walk you through is called tail. Tail displays the last lines of a file. So if you pass tail and you pass it a file, it'll just give you the last lines. Now, it gives you the last lines. It doesn't give you all the lines, so it doesn't have to read the whole file. So for example, if you have like a 100 megabyte file and you tail that file, it'll only output, I don't know what the default is, I think 20, 30, 50 lines, but it's relatively efficient. It doesn't read the whole file. It doesn't take, if you try to open a 100 megabyte file in most editors that are not in your command line, they're probably going to blow up. Tail won't. So in this example, and everybody's familiar with starting a Rails console, you see the output coming through. You can accomplish the same thing by just tailing the log, passing the -f switch to it, which tells it to wait for additional information. So the command won't really exit until you tell it to. So that means that as more requests come into the Rails app, you'll keep getting output. So how do you get more information about this or other commands I'm going to talk about? You use another Unix command called man. Man gives you the manual information. It sort of looks like this. By the way, you can call man on man, which is a little meta, and, but it should be interesting reading. So suppose we want to tailor a Rails log, and we're looking to get a list of requests that get made to our server. The Rails output that we had before is pretty verbose. It gives us information about which layouts were rendered and how long they took, and all sorts of good information, but that might not be what we need at a certain point. So we can use grep, which is a file pattern searcher, and filter this output, and only output the lines that match a regular expression. Any other lines will not be matched, will be thrown out. So in this case, the two commands, and I'll talk a little bit more about this just now, but the two commands are put together by a pipe, or the vertical var you see there, and that is what I was talking about, where the output of one command and the input of the other. Tail's output is now being redirected to grep's input. Grep takes as an argument a regular expression. You can use extended regular expressions too. In this case, I just basically said any line that starts with the word started, S in uppercase, they're very specific, will be rendered, everything else will be thrown out. So a little bit more about what's going on. A Unix process is, in the simplest terms, is an instance of a running program. So in the previous case, we had grep, tail and grep, both are instances of a Unix process. And Unix processes have three standard streams, and those are standard in, that is the data that's going into a program. By default, it'll be the keyboard that started that program. So most Unix processes, if nothing else is told to them, they will bind to the keyboard and will receive the input from the keyboard. They have two output streams, one called standard out, which is where the program is expected to write its data out, and it defaults to the text terminal that initiated the program. That means the terminal where you typed it. And there's standard error, or standard error, which is another output, much like standard out, but it's typically just used for error messages or diagnostics that your program should have. It's independent of standard out. You might want to have them redirected to different places, but by default, it's also redirected to your text terminal. And this will become important in a little bit. So everything is a file in Unix. So either of these standard streams can be redirected. So you can have a file connected to standard in. You can have a file connected to standard out or to standard error. You can mix and match any way you want. In the example we had before, the pipe operator, what's going on is really that the development log is being the input for tail. Tail's standard error, we didn't made any assertions about it, so it's still connected to the terminal. The standard out, though, is now connected to the standard in of grep by that pipe. And grep's standard output now becomes the terminal. So we sort of, as the Unix starts both processes at the same time, pipes the output from one to the output, and then we can sort of compose these programs as going forward. By the way, the vertical pipe is called an anonymous pipe. There are more advanced stuff that can be done with named pipes. That is usually more system-y programming kind of stuff. I won't cover that today, but it is possible. So let's say we have a big development log like the one we had, and we want to know how many times each endpoint has been hit. So I'm going to try to walk through the example and see, like, well, how will we extract that information using some command line utilities that are available in any Unix system, and see how will we do that. So first, let's start where we had before, just a list of the endpoints. In this case, we're not tailing the log, we're just grepping it directly. The input is the log, development log. By the way, grep can take more than one file as input, as many command programs can, but for this purpose, we only have one. But we're really, if we want to sort of create a tally of all the endpoints, we're really not interested about the IP addresses and the dates and the started or the method. Right now, I'm really just interested in the endpoint. So let's filter that out. We're piping grep to grep. That means that the other output, we're piping it again to grep itself. This time around, we're saying, I only want the part of the line that matches a certain regular expression, where in the case is everything that is between quotes. Regular expressions can get kind of hairy. I'm going to try to keep them simple for today, mainly because I can't write really big ones. But so now we have a list of endpoints. Now, some of these endpoints are repeated, and we would like to. We just want to basically, we want to get a count of how many times each one has been hit. Well, we need to count them in some fashion. So this is going to take a few steps, so I'm going to go through them one at a time. We're sorting them. So this is, I'm introducing you to the command called sort. Sort takes the input as lines, and by default does lexical sorting on them. That means 0 goes before 1, and then the numbers and the letters, etc. And then it has other options that you can use for numeric sorting if that's what you want. But for now, we're just using the sorting. It doesn't look like it's getting on much until we now pipe it to another program called unique. What unique does is reports or filters out repeated lines. So that's why we needed to sort them, because unique will take, if one line has already come before it, it'll filter it out. And this looks more like what we want. Right, so we have a list of endpoints in this application. Apparently, it's mostly about tokens. And if we look at them and we want to get some statistics about them, it seems we have, as far as the text goes, token/1 and token/10, for example, are completely different things. But we know that they're really just IDs for Rails. And we would like to count them as the same thing, right? Because for us, it's just like the same endpoint being hit. So let me introduce you to sed. Sed is a stream editor that reads input, modifies it, and writes it to standard out. So line by line, we're going to take each of this. We have the same output we had before, minus the sorting and the uniquing, because we want to do the uniquing after we've normalized it. And what we're telling sed is, I'm going to give you a regular expression, and the last part of the command is the sed, well, they call it the sed command. In this case, we're telling it S for substitute, and between the slashes, we have the regular expression to match and what we change it for. So in this case, we're saying anything that is a digit more than one, anything that's more than 1 digit long and all digits, just change it for :ID. And it does that for us. So now we have user/ID, user/ID. So where before we had user/1, user/10, both of those now become user/ID, for example. So now we have them normalized. We can go back now to sort and uniquing them again. And this time around, they look more normalized. We're passing, at the end, we're doing a little trick called unique. You can pass it a -C, which tells unique to give you the output of a count. So you see now my output has numbers, like 113, / 1 for user sign in, etc. So this is the counts of each one has been, the amount of times in the input that each command has has been found. And one more step, if we just sort in reverse, now it's sorting by the number. So basically we get like the top hit endpoints. So it seems 267 times we hit the tokens, the 113, etc. So a little bit of the command line and we get the command that we wanted. There's still some normalizing to do. If you see at the bottom there's like 2 starting slashes because Rails will route it correctly. There might be like tokens with the slash and tokens without the slash. We could keep going with this. But so the basic idea is a few commands we're using grep, sort, unique, set, give you some non-trivial processing power for processing text. I don't know about you, this reminds me a lot about map reduce. We start with a very big log, we just filter out the lines that we want, then we manipulate those lines and say, oh, I just really want a portion of those lines. Then well, let's normalize them and remove the IDs, put the IDs as an ID. Then, well, let's count those and sum them up into a thing. It's something in Ruby you could see this as starting up with an array of lines and then mapping them or calling select on them and then reduce and ending up with your end result. The thing about Unix's processes, though, is that there's something relatively interesting going on. When we have all these commands, in this case we have 1, 2 greps, 1 set, 4 sort, 5 unique. All right, we have 6 processes. They are started by the operating system at the same time. It's not like execute this, and then when you're done, execute the next thing, and then when you're done, execute the next thing. They all started at the same time, and the inputs are connected. And as long as the programs don't exit, they're still running. And the previous diagram showed the connections from standard in to standard out as being like together, but really the operating system under the hood is buffering the data flow from one to the next. So for example, if your first command is grabbing something from the internet and it at times be very fast and at times be very slow, but the next process only processes, say, at 1 megabit per second or 1 kilobyte per second, the operating system, up to a point obviously, will buffer the rest of the data and make everything just work seamlessly. So each individual program doesn't need to know about buffering and keeping a buffer and reading it and cleaning it up. That is done by the operating system. So that's why I made the little diagram in this way. It's also very efficient because the parts that are, when the program is done with that part of their data, they don't need to keep it in memory. So they only get, because everything, a lot of is just working with text files, and text files are preferred in Unix system as opposed to binary files. Most of these programs operate on a line-by-line basis. So as soon as they see a line end in the buffer that it's coming in, they can process it and move them to the next line and pass it on to the next process, which from the process perspective, they don't really know if they're connected to another process or not connected to another process. They can find out. And we're going to see an example of some processes that do behave a little bit differently, if they're piped or they're not, but they don't have to. So this makes it relatively efficient. You can make pipelines that are relatively efficient. There was a blog post somebody posted about doing some huge data analysis, I forget on what, and their assertion was that using it on a multi-core system and using standard techniques like what I just described was faster than using Hadoop in the cloud because, well, Unix systems are very efficient at processing text. All right, let's do let's do more examples. So finding inside files is something that we usually do as programmers. You want to refactor a method, you want to see which classes are using some other class maybe, and grep is great for that. It can be kind of slow, especially if you have a large code base. And it has a few competitors. There's ACK and AG. ACK is like grep, but it's more optimized for day-to-day programmers. It's written in Perl. And AG, also called the silver searcher, is like ACT, but it's written in C, so it's even faster then. And the things that they do for you is, for example, if you have stuff in your git ignore files, like log files or stuff, they won't search those, which makes it, so they can get pretty large. That makes it more efficient. You can add stuff like .ag ignore files that specifically tell, for example, in my projects, I don't really care about the JavaScript, so don't search there. Somebody else is writing that. I just care about the Ruby files. Yeah. On a Mac, you can get it with brew and install brew install AG. On Linux, use apt-get, I guess, or whatever else is your package manager is. So let's, for the sake of argument, let's say we just upgraded our factory girl gem and we want to know what specs are using it to run those specs, and those specs only. So we use AG and we tell it, find anything that's called factory girl. By default, it'll search all the files in the current directory and the trees below it. And it gives you a nice output. It shows you the file, shows you each line number, and shows you each line with the line number of where it was used. It's really easy to use this output and then go to your editor and look it up. Depending on what editor you're using, you can integrate it with AG. It's really useful. Now, in this form, though, it's really not like, if we wanted to run all the specs, we would need to like manually copy paste, run them rspec, and call this spec. This is not something that's fun, but we can do a little bit better. So we can take the same output and pipe it to grep. There's an interesting thing going on here. AG does check if you're connected to the terminal or if its output is going to a different program. So if the output is going to a different program, it gives you a different output. It gives all the output in one line, which is more like the standard, what grep would do. The output looks more like grep, so you can use them interchangeably. So in this case, we're grepping and saying anything that starts with spec and ends, has something in it and ends with spec or .rb, those are the ones that I want, not anything else. The reason why we're doing that is because we don't want the factories to be piped into rspec for execution because they're not really spec files. Okay, so now we have a list of controllers. It's a list of specs, I'm sorry. But we still can't execute this. But again, we can do our old trick about just grepping part of the output and doing only matching. There's a few other ways we could have done this, but I like that one. And so now the output is limited only to the part with the file name for the specs. We do sort unique again because some of the specs use factory girl more than once. We don't want to repeat them. And now we have a list of specs. So how do we run this? Usually you can, the way you run a single spec with rspec is you say rspec, and then as arguments you pass in the list of files. There's something for that, and it's called xargs. The description is a little bit opaque. It constructs an argument list and execute utility. But what it does is it takes the list that we had before and passes on as arguments to the command you give it. So in this case, you say whatever we had, xargs rspecs, it'll actually call, what it's doing under the hood is calling rspec with the list, you can see down there, with the list of controllers, and then you can execute your specs. So sometimes when I'm doing this kind of thing, it's easy. I find, I'm looking for data and I'm hunting it down, and then when I get it, it's like, oh, I have all these commands that I can execute again in my shell, but now I want those to be executed to something else. Xargs is very handy there. It can be also used with copy, find, rename. As anything else, it doesn't make any assertions on what command you're piping the arguments to. So I find that relatively useful. I have one more example for you. This is really a personal pain point. I work on a lot of projects. Some of them are very large. Some of them use JRuby. Some of them use MRI. And Has anybody used JRuby here? All right, it's slow to start up. It's really slow to start up, especially on complicated and apps that have a lot of gems and a lot of code in it. It can take like 30 seconds, 45 seconds just to boot. So there's a few ways to alleviate that problem, because if you want to run a spec and it takes 45 seconds just to load and then run your spec, it gets really old. There's a thing called Spork, which is sort of like a Rails loader that loads everything up in a thread and then opens up a server. When you execute it, you tell RSpec that you want to use a distributed server. It listens for that, runs your spec, and then throws that thread away, but keeps the warm copy of Rails running. And well, actually it doesn't. It boots several Rails instances for you, like the number you tell it, but usually 2. It runs one with your specs and then throws that away and starts booting another one. So if you run another spec, it uses the one that's already warm. So it uses a lot of memory, but it gets your test running faster most of the time. There's another thing called Zeus, which is similar to what Spring comes with Rails nowadays, but it doesn't have to be in your gem file, so it's a little less intrusive. But it basically does the same thing, but with Unix forks. That means you have a process and you fork it, so you now have a copy of the other process. It's just not compatible with JRuby. JRuby doesn't work. Anyway, this is a completely personal pain point, but bear with me. Sometimes I run RSpec, sometimes I run bundle RSpec, sometimes I want to use the bin stubs because now everybody wants bin stubs. Sometimes I want to call DRB on it. I can't keep track of this. It's distracting. So, oh, and I forgot about one. The one that says JRuby --ng, that's for Nailgun. That's sort of like the same thing that Spork does. It warms up, but it's just for the JVM. Like it keeps a warm copy of the JVM, you use it, and then warms up another one. Yeah, I go through a lot of hoops. So let's write something that does this for me, and then I don't have to worry about how to do the invocation. So first let's start with let's write a script. A bash script, if anybody doesn't know, it's just really a text file. You tell it that's executable with chmod, chmod. All right. Yeah, I type it. I don't. Siri, chmod this. All right. Usually you add what's called a shebang line on top of it that tells the shell what to interpret this as. You can do this for Ruby scripts as well. But so let's start. The first part we want is you're inside a project. We want to know if we have bin stubs, let's use those because presumably they're there for a reason. Otherwise, let's fall back to bundle exec. So this is bash programming or scripting. The if-f inside the brackets means that what we're doing is checking for the existence of a file. It'll return false if the file doesn't exist, true if it does. Bash is really particular about the spaces around the brackets. Tread carefully. It's the errors that it gives out are not very friendly. But anyway, so we decide what the RSpec command is going to be. So it's either going to be bin RSpec or bundle exec RSpec. And then there's a magic variable here that's called $@ near the bottom. That variable is any argument that was passed to this command. And what we're doing here is accepting any argument and just passing it on to RSpec. So if you call it with a file or you call it with some options for documentation, whatever you have, just pass them on. I'm echoing the command so I know what we're running and then running the command. So now we have the first part. We're either running bin RSpec or bundle exec RSpec. Now let's think about Spork. So as I said, Spork is Spork opens up a port and listens for commands on it. So how do we know if a port is open? That's what we want to know, if Spork's running or not. For that, there's another utility called LSOF, similar to LS, which probably everyone's familiar with. It lists files. This one lists open files. And it happens that you can also list for a port. So in this case, say you have a Rails console running. You tell it, list for an internet port at port 3000, and it shows you the process and the process ID and everything about that process that has that port open. Now, in Unix, every process has an exit code. When you exit, you either exit with an error or you exit successfully. 0 means you're successful. Anything else means there's an error. So we ran our command, and then if we echo, the magic variable for the exit code is $? Question mark. By the way, these are really easy to pronounce, the magic variable. So for example, if you try to open on a non-open port, it won't give you any output, and the exit status will be 1. So we can leverage that in our script and say, well, the spork port is 8989, and after I've decided if I'm going to do bin stubs or not, then I'm going to look for the open port. If you see the line when it starts with LSOF-E and the spork port, this is, I created a variable and then I interpolated it. And then I don't really care about the output, and I don't want to see it when I'm running my spec because I don't really care what the process that has the spork open is. So I am the greater than that sign. What that's doing is redirecting the output to a file. Which file? Dev-null. Dev-null is a Unix construction. It's a device that just basically throws away anything you give it. So in this case, I'm only redirecting standard out, not standard error, but we could have redirected both. It doesn't really matter. But what we do care about is the exit status. So if the exit status is 0, it means that the port is open. So that means that I want to call rspec with --drb, so rspec knows that it needs to send the command to a port. If otherwise, then the drb won't be added to the command. So that gets us to this thing knowing whether if use spork if it's open or not. Nailgun, which is the JVM startup, works just exactly in the same manner. It's just on a different port, and we do the same trick. In this case, we do it beforehand because the way to invoke this is you need to expressly tell JRuby to use the --ng so that it uses nailgun, and then call whatever the incantation is, so the rspec command goes in the end. But we can hook it up. And then lastly, for MRI projects, or sometimes we have projects that can boot in both modes, I use Zeus, which is the preloader. Zeus works a little bit differently. It doesn't open a port. What Zeus does is it communicates between the processes with a socket file. And a socket file is like a special Unix file for inter-process communication. It's, you can pass data and file descriptors in it, and it's a little beyond this talk what sockets really are. But for our purposes, sockets is a file that looks like it's a file in your file system. And by the way, sockets are a better solution than ports because you can have, like I can have Zeus running on one project and another terminal have Zeus running on another project. They don't interfere with each other. Where there's Nailgun, because it uses the same port, you can't bind to both. But anyway, what we're doing here with at the top is finding if Zeus is running, checking with capital S for the existence of a socket file. If you just check with like the -f we used before for checking for a file existence, it won't work. There are different types of files. And then if we do, then we run the command changes to be Zeus rspec. So we either have the MRI way of doing things or the whole JRuby doing things. This is pretty much what it is then, what it looks like in the end. So how does it work? I basically just use it like this. I'm in a project, I run my smart spec, pass it in whatever I want to run, and it does the right thing. At the top is using Nailgun, it's using spork with the --drb, is using bundle exec. In another project, it's using the bottom, it's using Zeus. So I don't expect anyone here to use this like, oh, that was what I needed because it's very particular to me. However, this saves me a ton of time, especially in thinking like, oh, how do I actually run? What am I have running? Do I have spork? Do I don't have spork? Like in projects where I don't have spork running, if I run the spec, it still runs. It just takes longer to run, right? So what I really want is I don't want to think about this. Just run my spec. So it saves me from context switching. I did a little bit analytics on my history. This is the command I use the most in the command line, besides git. So this is how much I use it. So git, then smart spec. So But it's kind of the point that this doesn't apply directly to you. So my idea is everybody uses their system in a different way. Some people like to use the editors and use Vim and want to hook a lot of the stuff up directly in their shell. Other people like Atom, like I do, or whatever it is. But we have a very powerful operating system at hand. And there's a lot of ways that you can customize it and use it to your advantage. So the Unix interface is small collection of small programs, and I just scratched the surface. There's obviously a lot more. And it mostly works with plain text, which is great because we mostly work with plain text. We work with log files, we work with Ruby files, JavaScript files. They're just text files, but they can be composed together to great effect. Now, I previously said that it was similar to what we were saying to MapReduce, which is functional notion. People that use functional languages are very in tune with this. But the notion of small things and composability is also very object-oriented kind of thing. So, for example, as Rubyist, this notion should resonate, right? We make software all the time. We use Rails apps. We use small components in the standard library. We use the thousands of gems that are available that are small things geared to solve a particular problem, and then bring it into a project. And of course, we use our own classes, which they're all small, right? They're not really big. Yeah. If anybody has seen or read Sandy Metz's books or talks, she talks a lot about building small things, right? And her advice is for Ruby is like build small classes that do one thing, and then you can compose them together. And that advice is also generally applicable to object-oriented programming in general. Like if you're a Java guy, that also applies. The Unix folks that started writing Unix in the 70s have been building small things for a long time. So this notion carries forward in more just than object-oriented programming. That's it. That's my talk. I hope you guys enjoyed it, and I inspire you to write a few scripts of your own and do stuff more efficiently. Thank you. Yeah.
I just wanted to say thank you very much for having Xargs in there. It is the Unix power tool from hell. It is amazing. Read the man page. He's right. It is opaque, but it has a lot of really powerful tools in it, including automatic parallelization and all sorts of other things. So it's the true badass in that slide set.
Thank you. That's one vouch for Xargs. Anybody else? Yeah. Yes. So sorry, let me, I need to finish up, but I have, if you haven't seen Destroy All Software in the talks by Gary Bernhardt, he does some things on the command line that will amaze you. There's a really good, they're short, they're very, very dense though. Something like you need to watch them a few times. You're like, wait, what? What did he just do? But they're very, very good. There's a few things here. I will have my, the slides up in my blog probably today when I get back home, and we'll tweet about them. I'm Ylan Segal at Twitter and GitHub, and that's where you can find. But yes, I will have them online. Thank you, guys.